Welcome guys. So in this video, we want to do this problem by using a complex number. Okay. So I would say this is the prototype that how to use a standard complex number to solve the integral. Okay, so very easy video. Okay, so let me quickly remind you guys the standard results. Okay, so let me just tell you your answer, right? So the answer is arctangent x plus constant. Okay, so the standard real solution is that you use the trigonometric substitution. So this is really stupid, just that x to be tangent theta, and you get a second square, and dx will be second square d theta. Okay, so you get the integral theta, you get theta, right? So just arctangent x. Okay, so now let's go to the second solution. So second solution is our main goal is to use the so-called complex number. So easy to change x squared plus 1 to be x plus I, right? X minus I. So this can turn into 1 over x minus I minus 1 over x plus I. 1 divided by 2i. Okay, so simple integration will give you dx 2i x minus I minus dx 2i x plus I. Okay, so you get 2i log x minus I minus 1 over 2i log x plus I. You get 1 over 2i log. Basically, this is the natural log, right? X minus I x plus I. Okay, so up to now, this part plus constant, right? This part is really important. So usually in the calculus that people like to do this, right? But remember this absolute value just tell you that the x must be positive, right? This absolute value just make sure that the log only take the positive part, take the positive number, right? But in general, we are working in a complex number, right? So you cannot add the absolute value here. And the key idea to somehow shorten this expression is to use x. So you must remember that our x still be real, right? So let's see. So one can write x minus I into some polar coordinate r times exponential minus I theta. And from here, that your r will be x squared plus 1, and then your theta will be arctangent 1 over x. Okay, so this is easily be see that this is x minus I, right? So x is some real part, and this is minus theta. Okay, and so x plus I just from this picture, you know that is r exponential I theta, right? So this expression can be easily shown as 1 divided by 2i log. So you divide these two, so r and r will cancel. You get exponential minus 2i theta. So this part will be negative theta, right? So you get a negative arctangent 1 over x plus some constant. Okay, so final results, and the final is the final key identity. What we need to use is that you know that the tangent arctangent x plus arctangent 1 over x is basically pi over 2. Okay, and this can be proved by let's quickly prove. So proof can be, oh by the way, x should be any real number, right? So one can easily prove this by looking at arctangent. Let's see. So one can easily prove this identity by, let's say you let this to be alpha, this to be beta, right? So your tangent alpha will be x, and your tangent beta will be 1 over x. So easy to prove that tangent alpha plus beta will be tangent alpha, tangent beta, 1 minus tangent alpha, tangent beta. And you see this is 1, right? So that means that the alpha plus beta must be pi over 2. Okay, so yeah, so this is a proof. Okay, so one can use this and put this become arctangent x plus pi over 2 plus c. Let's see. minus pi over 2 plus c, right? But who cares, right? Because c can be absorbed a constant. So once you use this, then you still get some arctangent x plus constant. Oh, so which shows that this complex method is the same as you use a trigonometric substitution. So that means in general, so if somebody give you 1 divided by p of x, which p is just some real polynomial, with real coefficient, or I mean, yeah, real coefficient. Then if you want to do this, then you can separate this px into like 1 over like this type of form, right? And there's a power here. Okay, and you can change it as complex number, right? You can change this into complex number, and then remember that x is real, so you can modify the expression. Okay, so I would say that in general the answer will be arctangent something plus log something, or yeah. So this is the general form. Okay, so it's very interesting for you guys to have exercise to solve this by using a complex number, method. Okay, so simple exercise for you guys. Okay, see you guys next video. Hope you guys subscribe to my channel.